Hello guys, welcome to Freebirds2 and welcome to 75-day Hard Generative AI Learning challenge. This is day 60 and dangers of AI are known to everyone. Large language models still generate false responses, hurtful messages that can create chaos as well. So it is necessary to build large language model evaluation frameworks that can test them before we scale them to the larger audience. Okay, so from day 60 to day 70, I am teaching all of you about the large language model evaluation frameworks and how we can build it faster and better. So in this journey, our first step is to learn about the quantization that can shrink the size of the large language model by 10x or 15x as well. So let's get started. As you can see by this Kaggle notebook, the first step is quantization. So quantization is a technique that can use to reduce the computational and the memory cost of a running inference by representing the weights and the activation functions into the low precision format. Because as we know, when we are like building neural networks, our weights and activation functions are in the Float32 format, and Float32 format can take up more memory as well. We can see this kind of chart here. As you can see, the float can take up to 4 bytes and the double can take up to 8 bytes. But if we are talking about the integers, it can go a minimum value of short as well. If you can see this, we can see this long double can take 8 bytes. But if we talk about the short integer, it can take up to only 2 bytes as well. But its range is also very, very small. Okay, so we need to convert these high memory taking data types into the small data types to reduce the size of our large language model. So that's what is done by the quantization as well. So when we reduce the number of bits, means the resulting model require the less memory storage, consumes less memory as well, and also operations like matrix multiplication, addition, subtraction, all these kind of operations also work faster as well. Okay, if you see this, the floating point 32-bit data type can take up to 47 MB, but when we convert it into the Int8, it takes only 168 MB of the space. Okay, so that's what things can be done by using the quantization. Okay, and if you can see this, the high precision format like the floating values at 1.3, 1.4, but when we quantized it into the integer format, it goes like this. Okay, and there is one more important thing, that quantization does not mean it is a compression, because compression means we just take the original model, we compress it into a smaller form, like we compress the 4 layers into the 2 layers or 3 layers, like kind of things. So we don't do that here. We just try to make it a small model but keep the structure same. In compression, the structures get changed, but in quantization, the structure remains the same. Okay, so that's a very important thing, and it can also ask in the interviews as well. Okay, so now the main thing is quantization to float 16. Okay, because as I show here, the most common quantizations are float 32 to float 16 and float 32 to float Int8. Okay, so first we talk about the float 16 quantization. So float 16 quantization means we just directly converting the float 32 to float 16, because it is a quite straightforward, because it is in the same float domain only. It still has the exponent, it still has the mantissa of the parts of the floats as well. Okay, but we need to ask these kind of questions first before doing any kind of quantization. Does my operations have float 16 implementation? Does my hardware support the float 16, or is my operation sensitive to the lower precision? Because sometimes your lower precision values go into the NaN values as well, because those values are not understood by your large language model or by your own schema as well. So you need to check for these things as well. Okay, and then we talk about the quantization to Int8. So performing quantization to Int8 is very tricky, because we need to take care of this kind of range as well. Because as you see, the long or the double or float has a very large range. Okay, see, it has a very, very large range here. But the short range like unsigned char or short or unsigned short, it has a very small range. So when you are converting any value from the float to this kind of smaller data types, you need to change its range as well. Okay, so it has to be in this same range, so that things can be done. So only 256 values can be represented in the int8, while float can represent a wide range of values. Okay, so this thing can be done because you can only represent the integer values in the range of -127 to the +128. Okay, that things is only you have to check. So we need to find a best way to project our a and b of float values to the int8 space. So that can be done by using this formula here. So let's consider the float x is equal to ab. Then we can write this equation. The xq is the quantized int8 value. Okay, that is the our final answer that we need to get, and s is the scale. It is always positive for the float 32, and z is the 0 point. It is the int8 value corresponding to the value of 0 in the float 8. This is important to be able to represent exactly the value 0 because it is used everywhere throughout the machine learning model. Okay, because we need to set that where this 0 value correspond to the int8 space, that we need to check as well. And now the float 32 values outside of the AB range are clipped to the closest representable value, because here this is our range, because we need to set a kind of a range between the A and between the B as well. So this X value can be in between these two ranges. These two ranges are -127 or +128, and we need to clip it. And when we clip it, so it will give us that kind of value that we can use in our large language models. Okay, so in that way this whole equation thing works. Now the quantization in machine learning is the process of converting data from the float to the smaller precision like int8 and performing all the operations at the end as well. So this thing will work in the same way. Okay, so we have this quantization. We just try to project or represent the floating kind of values in the integer space as well. So these things are done, but the main question remains are how the accuracy is recovered in the quantization, and how doing calculations in int8 or FP32 give the same results. Okay, these things we need to check, because these things are the most crucial thing. If you don't take care of your accuracy, because in the high precision formats your accuracy is also too high, but if we reduce the precision, so our accuracy also got dropped. So we need to take care while doing the quantization, the accuracy should not get dropped. Okay, so for this kind of thing we'll answer in our next video, and in our next video you will see that how I can answer these kind of questions as well, with examples and with mathematics as well. Just be with it, and we'll meet in our next video. Okay, so and if you want to know more about the prompt engineering, generative AI, data science, you can watch my YouTube videos and also read my blogs on Medium. We'll meet in our next video. Thanks guys, thank you so much.